Hi folks, it's Steve here from Analytics in Action. What I want to do today is give you an introduction to spatial queries in SQL Server 2012. Today I'll talk about 5 things. What are spatial queries, why use them. Then the basic concepts behind creating spatial queries. I'll then provide you access to the demonstration files so you can work along with this tutorial, and then we'll just jump straight in and create and execute some spatial queries. So we'll do a number of queries. So we'll calculate lengths of objects such as line strings. So a line string is essentially what would be used to calculate, say, a route, say a road trip. Also do some calculations of areas within polygons. Then we'll do some work on buffers around geometry. So a buffer is essentially the area around an object. So for example, a line string such as a route, if you put a buffer on it, say 20 meters on either side, it would essentially, you could use that buffered geometry to determine whether a, say, coordinate fell outside of that defined buffer. So for example, if someone deviated off a particular route. Okay, and then I'll talk about additional resources you may find useful as well. So what are spatial queries and why use them? So essentially, spatial queries are around querying geographic data, so coordinates, latitudes, longitudes, positional sort of data. And this is a really big growth area, and it's been a growth area for the last probably about 4 or 5 years now. So particularly with the growth of smartphones, so most smartphones have GPS information or generate GPS information. And there's also in-car GPS systems, and then there's all these other technologies, right through to these home detention bracelets, which identify the location of prisoners when they're meant to be when they're restricted to, for example, just staying at home or being at their work premises, or perhaps a route between the two as well. And of course, with spatial information, there are huge volumes that are being generated. I work for a company, and every second essentially there are megabytes of information being generated from in-vehicle GPS data. And as a result, because there's so much information being generated out there, there's growing opportunities in the analytical field to analyze it. So most people are familiar with services such as Google Latitude or Foursquare. So obviously those sort of services identify where you are. They also identify where, say, your friends are, but also where there are perhaps services which you may be interested in, such as a particular restaurant that may want to offer you a service or a discount. So there's so with this sort of detailed information, there's huge opportunity in the analytics field. So you can start running things, combining spatial queries with, say, predictive analytics to predict what sort of service perhaps you should be offered when you say come within a certain range of a certain vendor. So there's all sorts of smart stuff that can be done in this space. So I'll just go on and talk about some of the basic concepts behind spatial queries. So one of the key things is spatial reference identifiers. So these are essentially it's a system which will can be used to identify your position on Earth, and there's a whole lot of different SRIDs. So essentially what these systems are is they are sort of like a mathematical system which will, as I said, define the position on Earth, but you can use different spatial reference identifiers for different areas on Earth, or you can have very generalized ones as well. So some are more accurate in certain parts of the Earth, others are more general sort of forms. So We'll use probably one main one in this tutorial, which is the 43226, which is a generalized spatial reference identifier. So that's probably about all you need to know about them. The other thing is well-known text. So it's essentially, as I've got written there, it's an industry standard for representing coordinates on a sphere, or a geoid is a technical term. So it's essentially a sphere which has been flattened a little bit. So it's essentially, a point can be represented by single coordinates, and say a line string will be represented by a number of connected coordinates. Essentially, this could be a series of latitudes and longitudes that then get connected up into a line string. The one final thing to cover off is that spatial queries use a different syntax to standard transact SQL or SQL. So they uses these methods and properties defined by common language runtime data types, and I don't want to go into detail about this because it does get sort of complicated quite quickly, but essentially it just uses a different structure, and I think once you've got a few sort of concepts under your belt and you can work through a few examples, you can actually you can do quite a bit without having to develop too much understanding about CLRs. Okay, so just in terms of the structure of these spatial queries, the typical structure is they have a data type, which is either a geography or a geometry. So a geography relates to a position on a sphere or a geoid, while a geometry refers to one of these, a flat map, one of these projected sort of mapping systems. Today we'll talk about just these geography data types. Then we've got a method, which is essentially what sort of shape you're talking about. So whether it's a point or a line string, like I was saying, like a route, or a polygon, which is say the outside area of a property. And then you have the well-known text, or WKT, and that's just really definition of say a point or a line string, and then you define what the SRID is, and that's really the basic structure of a query. So what I'll do is you might want to work along with this tutorial. So I'll jump across. So if you jump across to my website is analyticsinAction.com/spatial, and you can also get there by clicking on resources, and it's sitting in there. It's running a little bit slow today, and you'll be able to just click on the tutorial, and then I've got down the bottom here, I've got demonstration files here, so you click on that and it'll pull up the demonstration files. So once you've got those, spark up SQL Server 2012, and then what we need to do is we just want to do a couple of things. So, well, actually the first thing is click on new query, and then let's go across and we'll copy the whole lot, all of the code across. It actually looks like quite a bit of code here, but we'll actually run through it fairly quickly. So copy it. And if you haven't done too much on paste it in, if you haven't done too much on code before, it might be worth going and having a look at my my Transact SQL tutorial. So where is it? It's in here somewhere. Click on resources, Introduction to Transact SQL. That'll give you a little bit of an overview on just using SQL Server Management Studio and running queries in it. But once you've you may not need to do that. So first of all, I'll give you actually a scenario of what we're going to do. So we're going to I'm not too sure whether you guys are familiar with a guy called Kim.com. So essentially he set up Mega Upload. He actually just lives just up the road from me, and he's had a bit of a hard time from the US government. He's currently going through the court in New Zealand. So I just thought I'd actually run a scenario of him having home detention, and he is allowed to only stay in his property and travel along the route to court, and only allowed to travel backwards and forwards. So actually, I'll just jump into my Bing Maps. I'll pull up some pictures of where his property is. Oh, my places. Here we go. Kim.com. So he lives, I think, probably about 10 k's away from me. Kim.com's property. So here's his property, and what we want to do is do a number of different spatial queries. We're going to assume that he's had some GPS tracking on him. He's had a home detention bracelet, and as I said, this is his property, and he's been allowed to travel along this route to central Auckland, across the Auckland Harbour Bridge, catch up, and to Auckland High Court, where he's been having his court cases. So we want to do a number of different spatial queries relating to this relating to the tracking of Kim.com. So first of all is we want to view a polygon in a spatial map. So essentially we've got this this query here. So this is the geographic data type. We're going to this is as I've mentioned before, this is the method. We want to do a calculation of a polygon, or view a polygon, and this is the definition of it. So this is the latitude of the first point, longitude of the first point, and its associated latitude. This is the second coordinate, and this is essentially, this query here defines his property. So what we do is just execute that, click on spatial results, and we see this is the shape of his property. And if you go, yeah, there we go. So essentially this is just viewing it within SQL Server. The second thing we want to do is view his route from home to court. So this is exactly the same sort of structure: geography, data type, the method st line from text. So we're just going to look at a line. It's a line string. So, and these are the coordinates of the line string. So let's just highlight that. And we're using this spatial reference identifier here. Spatial result there. So this is the route through to court. So at the moment there isn't really good integration with say Google Earth or Bing. So we've just got a fairly rough sort of picture or a representation of the route, but you can actually use, say, reporting services and render this over say Bing Maps fairly easily. So that just highlights, say, the route, as I said, the route that he's following. That's the shape. That's cool. And so the next thing we want to do is actually just test, calculate the area of his property. So let's go down. So again, what we're going to use here was the same structure for the query, but what we're going to do is, first of all, we're going to declare a variable. I'm just going to call it plot. That's the name of the variable. It's it's a geography data type, and we're going to set the variable plot as this shape. So again, we're using the same structure: geography, poly from text, it's a polygon, and then we put in the coordinates, and as you see right at the end here, I'll have the spatial reference identifier. Actually, this uses a spatial reference identifier which is in feet, so And the only reason I do that is because that's what I've currently got Maps and Bing Maps in. So let's just run that. Oh, so in the final bit here is we're going to select the variable. We're going to calculate the area, and this is just an alias here. So let's just run that. So that's saying his property is, I think, that 1.4 million square feet. So if I actually jump onto Google Maps, it actually has that calculated. Google Maps actually calculates that here. So 1.4 million square feet. I have the same query down here in square meters as well. So this has the different spatial reference identifier to. So just jump to the end there. See, that's in 4326, which is a metric spatial reference identifier. Execute that, and that's exactly the same information. So next we'll calculate the length of the perimeter of his property. So again, we're going to declare a variable. So declare. We're going to call the variable perimeter, sorry. It's going to be geographic data type, and then we're going to set it, and then we're going to use the same structure of the query. It's geography, st poly from text, and then we're going to define the polygon. And then we're going to do a select query here. Select the variable, calculate the, we're going to use the st length method, and then again we're just going to call a column as perimeter in meters. There we go. So obviously this is just an alias here, so we could call this, anything. And if I update, run that again, there we go. It's just changed the name of the column. Okay, so getting on to some more practical sort of stuff, we'll calculate the length of the route from home through to his home on the North Shore through to court. So again, declaring a variable, we're going to call this home to court. It's geography. We're going to set the variable home to court, and again we've got geography data type. It's we're going to use the st line from text method, and these are the coordinates, and this is going to be in meters because we're using this 4326 spatial reference identifier. And then we're just going to go select the variable, what is the length, and we're going to call this length route. There we go. So what it's saying here is it's 25,780 meters. You can also do things like add a calculation in there, such as divide by 1,000, length of route, kilometers. So if we then run this, oh, so it doesn't like the space there. That should be a little bit more friendly. There we go, length of route in kilometers. Okay, so Kim.com is actually really keen on flying around in helicopters. Always seems to be appearing on TV with him and his helicopter. So what we'll do is we'll calculate the straight line distance. So a straight line distance is essentially uses the same length method. However, it only requires two coordinates, a start coordinate and the end coordinate, and it'll just calculate the shortest distance between the two. So again, declare, give it a name, helicopter route. It's a geography data type. We're going to set the variable helicopter route, and it's going to be geography type, st line from text, and then the coordinates, spatial reference identifier, and then we're going to alias the name of the column and call it length of route. So let's just highlight that. So that is now 16. That's 16 kilometers. Okay, so what we'll do is we'll move on, and we'll do a more complex query. So we'll run a see whether on his route from his home to court, whether he deviated off the route by more than, say, 20 meters. So first of all, we want to create a database of GPS positions, hypothetical GPS positions that mark the route that he followed. So first of all, we want to create a database. So select these. We're going to call this database Spatial Demo, and we're going to use the syntax create database, and then the name of the database to create it, basically. So execute it. So what you see is it won't appear there immediately. You need to click on this refresh button, databases, and here we go. See, it's appeared now. So what we want to do is now create a table within that database, and then this table is going to have a timestamp, longitude, latitude, and then we're going to insert data into the database. So let's just highlight this all, and I'll just show you the database once it's been created. There we go. I tried to create the database again, so I'll just see whether it's actually, because I ran this create database code by mistake. Let's just see whether it's actually populated information in there. So we just right click it, tables, route, select, right click again, select top 1000 rows. Okay, so it has populated it fine, that's cool. So this is essentially just a whole lot of tracking coordinates on his hypothetical trip between his home and court along that route. So let's just close that up. We'll jump further down. So okay, we want to answer this question: did when he went along that route, did he stay plus or minus 20 meters of the line string that represents his journey? So first of all, we need to define that route. So we use variables again. So we're going to declare a variable called test road. It's going to be geography data type. We're going to set that variable test road, again geography, and it's going to be st line from text, and these are the coordinates of the route. So this is exactly the same route that we visualized before, both on Bing Maps and also within SQL Server. And the next thing we're going to do is we're going to declare a second variable. So we're going to do this all in one go, and this is going to be the route buffer. So this is essentially that 20 meters on either side of this line string that we're defining up here. And so this is route buffer geography. You want to set it, route buffer equals test road, and it's this st buffer which defines the buffer, and this is going to be 20, as in 20 meters. And then the final bit is we're going to actually join those two bits together. So we're going to select this the route buffer which we've created here, and then we're going to say, does it contain the latitudes and longitudes from the table that we generated before? So let's just select this all. So this is the line, the route, and the buffer, and we're going to say, does it do the coordinates from this route table fall within the buffered area? And this is the result. So what it says here is that 1 means it falls within the buffer, and 0 means it doesn't fall. So let's just pull these up, copy those, and we can go to Bing. Actually, just when you put coordinates in, you actually have to have the latitude first and then the longitude, which is a bit of a pain that it doesn't recognize that. So let's then search that. Okay, so let's zoom in on it and see what's there. Okay, so this happens to be McDonald's in Albany. So this is the route. You can see he's gone down this route and deviated more than 20 meters off for a trip to McDonald's Albany. Surprise, surprise with the size of Kim.com. So that is I use this sort of stuff quite a bit at work. So I do currently I'm doing a contract at a fleet tracking company, so we'll quite often be checking the accuracy of the units. And what we'll do is when we test the units, we use a standardized section of road, and we don't want vehicles that have turned off that route when we've been testing the accuracy of the units. And so we can select vehicles to go into the trials by seeing whether they've actually stayed on a route or not. And okay, so what we can also do is calculate the area of particular geometry. So we did that before, but what you can also do is you can combine the area of two objects. So if we want to ask a question, say, okay, what is the total area in which the detainee, so Kim, can roam, including his home, plus a 2 kilometre buffer around the Auckland Central Courthouse. So what we do is we can do a couple of different things. So we declare the area of a circle. So this is the area around the courthouse. So we declare the variable. So okay, location of court. This is the position, and we want to add a 2 kilometre buffer around that point. So we declare declare a new variable, buffered point. It's geography data type. We set it. It's called obviously buffered point, and then it is uses this st buffer method, and the buffer is 2,000 meters, and that's going to select that. It's going to be called area around court. We do the same thing with the area around Kim.com's property. So his property is, we're using a polygon to define it. Again, we're selecting it, calling this st square meters, and then what we do, this final bit, is we combine the two areas together. We're creating a variable called total area. It's geography, and then it's we're going to combine the buffered. We're going to do a st union, which is another function. We're going to combine the buffered point around the courthouse with the the area around his house, and then we're going to do a select on that, and we're going to call it total. So let's highlight that all. That's it. Try not too much there. And then we just run this. So this will produce three outputs. So this is the area around the court, area in square meters around his property, and then the total. So those two add up to that. So actually the area around the court is huge compared to, it's an order of magnitude higher than the area of his property. So that's why this looks very similar to this. Cool. So that is pretty much spatial queries. So just get in and actually just have a bit of a play around with them, substitute your own sort of values in there, and you'll soon get the gist of it quite quickly. So as just to wrap up, if you found this useful, I'd suggest perhaps jump across to my in my analytics channel, subscribe to the channel, and that way every time I produce a new video you'll be able to you'll get updated, you get an email alerting you. And the other option is just to come across to my website and have a bit of a look around. There's lots and lots of information here on all sorts of things, integration services, reporting services, some of these new scorecarding tools like Spotfire. Also going to be doing some stuff on Tableau soon. Predictive modeling I've got information on, analytics in general, and yeah, lots and lots of stuff for anyone who wants to learn about business intelligence. So I hope you found this useful, and all the best.